So you use a backslash here and you use a slash here. You may also have observed that if you write a program that opens some kind of a path and you run it on a Windows computer, but you specify the path to the file with slashes, it also works. So Windows will accept both of them. So yeah, that's a path. You may also know that there are special symbols that have special meanings. For example, do you know what 2 dots mean?
Go back.
Go back one.
Go back one.
Yeah.
Previous one. Go to the previous directory.
Okay, so go 1 level up.
Okay.
And this 1 level up thing comes from the fact that you can represent the path as a tree. So it all begins at the root directory, and then here I have a folder called home. Inside home I have one called Alex, and inside this one I have a file called test bin. So let's mark files with bubbles and folders with just text. And then there are other ones, so you can have a huge tree that represents your hard drive structure. You may also know that there are some files that can have special data in them, valuable data. For example, on some it's either this or I think it's users. I don't remember exactly. Anyway, so it's a file that is present on Linux computers.
Password.
This one, yeah. That has the following format. So there are multiple columns. It's a plain text file. You can open it in Notepad and view it. Each line of the file contains the following details. That's the username, user ID, the path to the home directory, and it can also have the user's password, or to be more correct, the hash of the user's password. And do you know what hashes are, where they are used? So it's a one-way function that takes a string at the input of any length, and at the output it gives you a digest of a fixed length. This digest is unique, and if I change one thing here, then this thing is completely different. So they store the digest or the hash of my password there, and each time when I want to log on, I type the password is hashed. The hash is compared with the one stored here. If they are identical, then I get in. And another property of hashes is that this arrow only goes that way. Basically, it is not possible for you to reverse this process. But the digest has a finite length. For example, let's say 160-bit. Okay, let's take a hypothetical example of a 10-bit hash. So the possible options are 0, 0, 0, 10 times, then 0, 0, 1, 0, 0, 0, 1, 0, and then in the end you have just 10 1-bits. So we have a finite range of possible hashes. But the universe has an infinite number of strings. So obviously some strings will have the same hash. And this is called a collision. When you generate two strings that give you the same thing at the output, that's a hash collision. So this is a very superficial explanation of what hashes are.
There are two strings that give you the same?
there are an infinite number of strings that give you the same hash. Finding those strings takes a lot of time, so that's the hard part. But in this case, because we have a very short digest, it's easy. So imagine what you could do if you obtained this file. If you could somehow obtain a copy of it, you could then run a program that generates strings that give you the same digest. For example, if you know that this uses a very weak hash algorithm, or if you were some very, very rich person and you could just outsource this problem and buy the Amazon cloud for 1 month and make all of their computers calculate these collisions throughout this time. So in theory, you could do this in a reasonably short amount of time, given vast resources. And given that they use a weak hashing function for doing that.
This is called rainbow tables?
Yes, you can use rainbow tables to simplify the problem. A rainbow table is a huge table of pre-computed strings and hashes. So instead of generating each hash, you just look it up in the table.
Is that hash embedded somewhere to some particular file or something like that? To that file, let's see.
No.
Also.
It's something you compute on the fly.
Okay.
You take the string, you generate the hash, and then you store it here.
Okay.
So assume that I had access to this file, I could take the username and the corresponding hashed password, then I could take my time, go to the cloud, pay the money, let it run for a few weeks, and then I could know, I could generate another string, which if I input it when asked for it, the operating system will say, welcome, because the hashes will be the same. So in this case, it would be very bad for the people running this server if they somehow manage to get access to this file. Or, let's say, has anyone ever set up a PHP CMS or any kind of website? Usually, you have to give it some configurations, such as IP address to your MySQL server, username and password for the database, or other usernames and passwords. All of those things are stored in some PHP files, something like config.php, somewhere there. If somebody had access to that file, that would be bad for you because they would be able to extract the password and then they could log on to the backend, post spam messages, upload a picture of a penis instead of somebody's avatar. The possibilities are endless.
Yeah, this. You mean Apache has that conflict of INF?
So now I will give you an example of how I once avoided a path traversal attack once I knew that such thing exists. I had to implement a SOAP XML server. Has anyone done anything of that? Okay, so it's something that uses HTTP to send a request in the XML format, and then it gets back a response, which is then interpreted and something happens. A SOAP XML server has such a thing as, you can see them as functions. For example, you could have a server that has a function called multiply, and a function called divide. So at the input, you give it an XML file where you specify the operands using some predefined syntax. So the format of this XML file must be defined. And typically, SOAP XML servers have the option to give you a formal document that shows you how these functions have to be called. Basically, it gives you the interface of this function. in just like somewhere here, it was written f of x, which was integer, and it gives you y at the output. Do you remember?
Yeah.
Anyway, so see this as a computer function which has a given interface. Before I can use this SOAP XML function, I have to connect to the server. Let's say the server is test.com, and then let's say the service is called math, and then you would request, for example, the function is called multiply. Multiply. So I am making this syntax up. So path to the server, name of the service, question mark, name of the function. When the server receives that, instead of executing the function, it just tells me how to use that function. And the answer to the question how to use the function is an XML file, which is then parsed and interpreted. So my server had a bunch of functions in it. And the company that asked for me to create this one for them, they were not very clear with their requirements. So at first they said we need this, a few days later they said we also need that, and every now and then they kept adding more requirements, and then they would never stop. So I could never be sure that this is the end of it. So I had to think of some easy method that would allow me to extend this indefinitely without programming anything else. So I thought of the following solution to this problem. Somewhere on my web server, I had a folder. Let's call it functions. And inside that folder, they had to place an XML file, which they make on their own, and that XML file would contain the information the server would normally reply with when asked how the function works. So let's say they have a function called divide, so it would be their job to create a file called divide.xml, write the stuff to it and put it here. And so on, they would do the same thing for all the other ones they invent. In other words, whenever they want something new, I don't have to program anything. They just have to create another file, put it there. Then how would my server behave? When I receive the request, so it looked like this, test.com, math, question mark, and then function name. My server would do pretty much the same thing as the server of my students did. It would take this string, it would split it by the question mark, it would take the last half and keep it in a variable, let's say func. Then it would do this. fopen, so this is a string. Functions slash plus this thing here, then read it into some buffer and send that buffer to the client. So let's say they came up with some new function. This doesn't affect my code in any way, because if there is a new function, it will just be plugged into that string. All they have to do is just make sure that the file is present there. And then I thought, okay, let's make it a little bit better. What if somebody one day connects to the server and sends me a request that looks like this, test.com/math ? And then some random garbage. My program will go to that directory. It will see that it will try to open the file, but the file doesn't exist, so it will probably crash. So I took it one step further and I did this. Something like try to open it, and then I used this. If the exception was file not found, then I would return something like 404, which is, it corresponds for page not found, and all of these codes are defined in the RFC. So it's not magic, it's not some kind of a universal dark constant, it's just a number which people arbitrarily chose to use for such cases. So I did this, and I thought, okay, great. Now every time they invent something new, it's their problem, just put the file there, I don't have to change anything in my code. But, do you think something could go wrong?
The same thing, right? I mean, question mark. You're bifurcating based on question mark, right? So, the same thing.
Okay, so they could do something like just send something without a question mark, and then, but here's how I did it. In Python, for example, you have such a thing as list slicing, and let's say I have a list of strings and letters. And this is called X. With Python, I can use a negative index. For example, if I say print X of -1, it means take the first element from the end. So what I did, I didn't say split and take this specific part. I said split and give me the last part. So if there would be no question mark, it would just return this, so it wouldn't crash. What else? Remember that before I told you about this, we discussed paths.
Oh.
And I also highlighted the 2 dots case.
Someone can go to the parent folder by putting 2 dots, right?
Yeah. So basically, you got it. The attack would look like this. They would have to send me a request of this form. test.com/math ? And then my program would naively expect just one word, which corresponds eventually to an XML file in this place. But they would do this. So ? ... which would mean go up here, and then etc. this. So my program would open this file instead of that one. And then my program will happily give them the contents of that file. So that would be an example of a path traversal attack. Basically, it boils down to knowing where to put these 2 dots.
So the same, almost similar thing was present in Hack This Site.
Yes.
Okay, I haven't...
from level 9, you have to do a path reversal to go to level 8 and extract the password.
I didn't try that challenge, but now you know that there is a real official name for it, path traversal. And it's very simple. In fact, all the stuff I explained to you today is not about mathematics or super programming for people with very long gray beards and 50 years of experience in programming. All of this stuff is just a logical flaw in somebody's idea. In order to be able to spot such issues, all you need is common sense. Of course, it helps if you have pen, paper, so you could draw some lines and boxes, and it helps if you know which standards to read, so you could, push things to their limits, and it helps to know that dot stands for go one level up.
This is same as directory transversal as well, right?
Yeah, directory traversal,
Yeah.
another way to call it. So how would you protect yourselves from this?
From this type.
Yeah, so there are very easy answers. Try them.
You have to lock the. I mean, if one person is going to one particular section, he shouldn't have an access to the previous directory. Something
Okay,
like that.
so basically the program needs to be constrained to reading only from this subfolder and
Yeah.
below. Okay, now it helps to know your operating system and the instruments it provides. There is such a thing as chroot, and there is also such a thing as a jail. For example, this you can use on FreeBSD, this you can use on Linux. Effectively, what it does is what I just described. It prevents a process from going outside of one directory that you have specified. So this directory becomes its root folder. It cannot go above that.
Above that.
Another thing you could do, think about it. So if the trick is in putting these two dots somewhere, then what's the obvious solution?
Scan the input.
Yeah, so every time I get this string, I keep it in a variable which I called func. Then I would have to do something like this. In Python, you
Check.
could write
Check.
a very elegant
Check.
expression. If ... in func, then return error. So you don't have to have any for loops, or in C you would do something like str
Oh yeah.
something, and it's very, you have to do memory allocation. In Python, it's just like that. So yeah, the easy thing to do is to scan for two dots, and if you find them, then obviously somebody's trying to screw you up. But people, clever ones, know about RFCs. So if you read this one, you will see that every RFC has links to many other RFCs. For example, there is such a thing as a URL, Uniform Resource Locator. And somewhere here, I wrote post followed by the path. Well, that path is actually one of those, and you have to read the corresponding RFC to see what's the valid format of a URL. And you probably noticed this, not just once, that some URLs contain such thing as %20.
Mm-hmm.
%20 is a way to represent space. And in fact, there are many other %something characters which you can use to represent something else. And it shouldn't come as a surprise, but there is a way to represent a dot as %something. So, okay, you can train your program such that it looks for ... But then one day you'll learn about this %something trick. So then you would have to extend your program like this. If ... in this, or you could, let's just keep it in the same format. If ... is there, then return error. Else, if % whatever, I'm going to write x in func, then do the same thing. So I would just add a lot of other if-then constructs to my code.
%x, that's the same thing?
No. I wrote x as whatever. I don't know the exact number that corresponds to dot. %x stands for hexadecimal representation of a number. If you print that using printf. So in this case, it's not percent as a format specifier, it's percent. You know, for example, if I do \n, then it's interpreted as a new line. But if I really want to print \n, then I have to print \\. So in this case, I am looking for the percent sign. I didn't mean percent blah blah blah. I really meant percent and some number. So the solution to scan the string for some clever tricks works, but there is more than one way to represent ... So a method like this one would be much better because you do this just once and it works universally, whereas this thing, you would always have to think about other ways in which they could get at you. So those are path traversal attacks. Very simple matter of logic, nothing to do with hardcore science, just common sense. What are your questions at this point? So the cool thing about... Huh?
We would want to see all this now.
Oh yeah, we have to see that in action. So the cool part about application layer attacks is that they, remember that in the stack, and let's say this is the transport layer, these attacks happen up there, and usually defensive mechanisms are in the layers below. And because these messages are fully compliant with the formats given in the RFCs, protection layers here wouldn't be able to detect them as malicious ones. So you need to have an application layer firewall, something that is able to understand the abstract concept in order to see that, hey, this is an attempt to screw me up.
Okay.
And they can be, so the ones I showed you here are easily implemented. It all boils down to crafting a special string and sending it to the server. And all the examples we discussed today, they do not require thousands of hundreds of computers. You can do this with just one, and you could also buy a SIM card with internet access, use that SIM card to do your thing, and then burn it, destroy it, and that's all. So I'm going to turn on my computer so I could show you this in action. And while that happens, you can still think about questions. We don't have a projector, so you'll have to somehow just gather around me. I think I will move that way because most of you are already there. Okay. So I'm going to stop this.